Namaskar. In today's lecture for the paper of microwave electronics, in the chapter of microwave propagation in ferrite materials, we discuss the construction, working and applications of ferrite circulator. In our previous lectures, we have discussed the Faraday rotation effect in ferrite materials, and also we have discussed the construction and design and working of gyrator and ferrite isolator. Now in today's lecture we will discuss the construction and working and applications of 3-port and 4-port circulator. So first of all we define a circulator. As shown in the figure, a circulator is a multi-port device that has the property that a wave incident in port 1 will transmit through port 2, a wave incident in port 2 will transmit through port 3, and similarly from port 3 to port 4. A ideal circulator is also a matched device, that is with all ports except one terminated in matched loads, and the input impedance of the remaining port is equal to the characteristic impedance of the input transmission line. Now we will discuss the working of a 4-port circulator. So a 4-port circulator as shown in the figure may be constructed with the help of 2 magic tees and 1 gyrator. So as shown in the figure, the 2 magic tees are shown and 1 gyrator is also shown. As earlier we have discussed in our previous lectures that a gyrator is a device that has a differential phase shift for transmission from one direction to the other as compared to the phase difference with respect to the reverse direction. In the figure, the sides marked as A, B, C and D of the 2 magic tees, the electrical path lengths from A to B or B to A, similarly from C to D or D to C, these are same. In the magic tee, or it is a hybrid junction that is comprised of one E plane T and one H plane T. So this is the H plane T and this is E plane T. So it is the magic, as its name or the characteristic of the magic tee or hybrid junction, that any wave incident in port 2 will be splitted into equal and opposite waves that will emerge from these sides named as A and C, and these two are in the same phase and of same amplitude, and its converse is also true, that is if the 2 waves of same amplitude and are in the same phase and entering from A and C, they will recombine and emerge from port 2 and the port 4 will remain uncoupled. Similarly, if any wave is incident in port 4, then it will be again splitted into equal parts, but the 2 waves are out of phase and they will emerge from A and C, and its converse is also true, that if the 2 waves of same amplitude and of opposite phase, they will enter from A and C, and similarly in the next magic tee from B and D, they will recombine and transmit from port 4 and the port 2 will remain uncoupled. So this property of the magic tee we will use in the now working of the 4-port circulator. So now we will discuss the working, that if we consider first a wave entering in port 1, which is the H plane T. So as discussed, this wave will be splitted into equal waves of the same phase, and they will emerge from the sides B and D, and they will enter at A and C in the same phase. So therefore they have the correct property to recombine and emerge from port 2. Similarly, now if any wave is entering in port 2, which is again the H plenty, this wave will be splitted in two equal waves. They will emerge from A and C, and these two waves are in the same phase. Now these two waves, component waves, will enter B and D. Now, but due to the presence of the gyrator in the branch AB, it will provide additional phase change of pi in the wave entering in branch A to B. So it means that now the two waves entering at B and D, they are out of phase, and therefore they will recombine and emerge from port 3. Similarly, a wave entering in port 3, it will be splitted in two equal parts, but they were out of phase, emerged from B and D. Now these two waves will again enter at C and D, at A and C in the phase which is at the time of origin from B and D. It means these two waves are out of phase, and therefore they will recombine and emerge from the E plane arm of the hybrid junction, that is from port 4. And lastly, a wave entering in port 4, which is the E plane side. So this wave will be splitted in two equal parts, and they will be out of phase. Now these two waves, when enter at D and B, again due to the presence of the gyrator, it will provide additional phase change of pi. So now due to the additional phase change produced by the gyrator, now the two waves enter at B and D in the same phase. So they will now have the correct property to recombine with each other, and they will emerge from port 1. So in this way we have discussed the working of a 4-port circulator, that is a wave entering in port 1 will transmit from port 2, from port 2 to 3, and from port 3 to 4. So this is the one form of 4-port circulator. Now we are showing a compact form of 4-port circulator. In the compact form, the figure shows a waveguide, rectangular waveguide, in which there is an intermediate wall between the two sides, two ferrite slabs which are called the non-reciprocal phase shifters. They were placed in the two sides of rectangular waveguide. One dielectric slab which also produces 90-degree phase shift is placed in the one of the rectangular waveguide arms, and there are two 3 dB side hole couplers in the side wall. If we discuss the if we discuss the non-reciprocal phase shifter, so it is made up of a ferrite slab. It is placed in the rectangular waveguide at a position where the field is maximum circularly polarized, and a static magnetic field is applied along the y-axis. The length of the ferrite slab, which is placed in the axial plane, is chosen so that a differential phase shift of 90 degree, that is beta plus minus beta minus into L equal to 90 degree, is obtained. Now we discuss the working. So as shown in the figure, we have designated the ports 1, 2, 3 and 4 as marked in the figure. Now if a wave is entering from port 1, then at the 3 dB side hole apertures, it will be splitted in two parts, and it is the property of the aperture that the wave entering through it will have a 90-degree phase shift. Now when passing through a ferrite slab, additional 90-degree phase difference will be produced. So one wave which enters here in port number 2 will have 180-degree phase difference. Similarly, the other wave which passes in the lower waveguide will have 90-degree phase shift produced due to this dielectric slab. So the total phase is 90-degree. Similarly, the wave in the upper side of the rectangular waveguide, when it crosses the second aperture, then the wave is splitted, wave will again splitted, and it will propagate with 90-degree phase difference. So the phase difference will be here 270-degree in this wave. And similarly, from lower waveguide to the upper waveguide, in crossing the aperture, again the 90-degree phase shift will be produced. So this is the phase so the phase in this wave will be 180-degree. Now if we compare the phase difference in the port number 2, that the relative phase difference between the two waves in port number 2 will be 0. It means these are in the same phase. While in port number 4, the relative phase difference between the two waves is 180-degree. So they are out of phase. So they will destructive interference will take place in port number 4 and they will destroy each other. While in port number 2, due to the same phase, they will be constructively interfere each other. So a wave, it means enter in port number 1, will emerge from port 2. Now similarly, the transmission from port 2 to port 3 can also be explained. So if a wave is entering in port number 2, at the first 3 dB aperture, it will be splitted with 90-degree phase difference, and the second wave when reaches at port number 3, it will have no additional phase difference and moves with 0-degree phase difference, which is the initial phase difference in the wave. And in the second waveguide, when the first wave, after splitting from the first 3 dB coupler, it will be have 90-degree phase difference due to non-reciprocal phase shifter ferrite slab, and 90-degree due to resistive pad. So the total phase difference will be 270-degree in this wave. Also this wave when splitted here at the 3 dB coupler, second 3 dB coupler, then additional 90-degree phase difference will be produced. So it will have 360 phase difference. While the wave from the upper waveguide, when splitted at the 3 dB coupler, it will also have a phase difference of 90-degree. So the total phase in this wave will be 90-degree. Now if we compare the phase difference at port number 1, then it is 180-degree. So these two waves are out of phase. While in the port number 3, the two waves have a phase difference of 360-degree, at which the two waves are in the same phase and they will be constructively interfere each other. So it means a wave entering in port number 2 will be transmitted from port number 3 and the other ports will remain uncoupled. A similar transmission property can be explained from port 3 to port 4 and from port 4 to port 1. So this is the working of the 4-port circulator. Now we will discuss the principle of design of a 3-port circulator. So here we will mention the Carlin theorem. So the statement of the Carlin theorem is that any lossless, matched and non-reciprocal 3-port microwave junction is a perfect 3-port circulator. So to prove this property, we will write down the scattering matrix of a 3-port microwave junction, which is shown in equation number 1, in which the scattering coefficients S11, S22 and S33 are considered 0. Now, since the junction has no longer symmetrical, and for non-reciprocal junction, the scattering coefficients Sij and Sji will not be same, so they have unequal values. Further, for a lossless junction, the conservation of power requires that the scattering matrix should be unitary. So by the unitary property, St into S star will be a unitary matrix, that is the product of the transpose of scattering matrix and its complex conjugate. So it must be equal to a unitary value. So from the scattering matrix, here we have write down the transpose matrix and the complex conjugate of the scattering matrix, and it must be equal to a unitary matrix. So after taking the product of these two matrices and comparing the coefficients on the other side of the above equation, so this will gives us the following equations, that is S21 into S21 star plus S31 into S31 star equal to unity. Similarly, these two equations have unit value, while the other terms have 0 value as shown in the equations. Now if we further assume that S21 is not equal to 0. Now if S21 is not equal to 0, then from this equation, first equation, S31 must be 0, and when S31 is 0, this equation shows that S32 will not be 0, and when S32 will not be 0, then this second equation shows that S12 must be 0, and if S12 is 0, then this last equation shows that if S12 is 0, then it means S32 will not be 0, and if S32 is not 0, then if S32, it means not be 0, and if S32 is not 0, then S31 must be 0. So therefore we have concluded that S12, S23 and S31 have 0 values. It means there is a perfect transmission from port 1 to port 2, from port 2 to 3, and from port 3 to 1. So these results can be utilized in the construction of a 3-port junction. So these scattering coefficients now can be made by proper locations. The values of S13, S21 and S32 equal to 0 can be made by proper inclination of the tuning posts in the 3 waveguides. So this is the design of a 3-port symmetrical Y-shaped rectangular waveguide or a strip line version. So these are symmetrical. At the center, the required non-reciprocal property can be introduced by placing a ferrite slab or ferrite disc or post at the middle, and a static B0, static magnetic field B0 is applied. So this device, by the Carlin theorem, if it is non-reciprocal matched device, then this will act as a perfect 3-port circulator. So this is shown in the figure. Now we will discuss the applications of the Ferrite circulator. So one of the application is shown in the figure as a duplexer switch in radar communication. So in the figure, duplexer switch means the same antenna can be used for both the transmission and the reception. So it is a 4-port circulator is used with its 1 port. The transmitter, radio transmitter is attached. Port number 2 is connected with antenna. Port number 3 attached with a receiver, and port number 4 is connected with a matched termination. So if the wave which is entering in port 1, that is through the transmitter, it will be circulated towards the antenna, and the signals received from the antenna are transferred to the receiver only by circulating it from port 2 to 3. So it means that by using the same antenna with the help of a circulator, it will act as a duplexer switch, and the sensitive receiver can be isolated from the transmitter. The second application is shown in the figure. It shows the amplification of signals. So in this application we have used 2 3-port circulators. With the first 3-port circulator, input signal is entered in 1 port. It is circulated to parametric amplifier or tunnel diode, and the amplified signal is transferred to the output port of the second 3-port circular waveguide, and if there are any reflections, then they will be circulated towards the matched termination, which will absorb these signals, and they will again not circulated to the input signal. So in this way the amplified output signal can be obtained with the help of a circulator. Similarly, a third application is shown. It is used to improve the stability and the gain of the negative resistance parametric amplifier, in which a 4-port circulator is connected in the input circuit, and the signal generated from the generator is circulated towards the vector diode, and the output signal from after amplification is delivered only to the load, and the input resistance of the signal RG will remain uncoupled. So in this way the output at the same signal frequency omega s can be obtained with the help of circulator. If circulator is not used, then multiple reflections within the guide will takes place that will cause the instability of the system, and we could not take gain at the same frequency of the input frequency omega s. Also the gain by using the circulator will be almost 4 times if we are not using the circulator. So in this way, with the help of by using circulator in the input circuit, the gain obtained can be 4 times as compared to the circuit if we are not using the circulator. Thank you.